So welcome back students. This is nothing but our continuation part for this derivation. This is nothing but what, a lecture number 4. Okay. Continuation part of lecture number 3. So in previous class we had drawn this diagram and I had told you how we got V1. Okay. What is magnitude, next initial momentum, final momentum, change in momentum, and what is time. Now what we are going to do means, first of all, I will be erasing all this part. We want only delta P by delta T now, which is nothing but what, a force F. Shall I erase this part completely? Okay, just. So let me write here, derivation we are doing for average pressure okay. Now delta P equation what we got, 2 times of m v1 x, clear, 2 times of m v1 x, and delta T value what we got, delta T value is nothing but what, a 2L by V1 x. Okay. Now delta P divided by delta T, if I cross check, means F is nothing but what, rate of change of momentum, delta P by delta T. Clear? Now substitute the values. This is nothing but for x we are calculating, means this is F1 x. So delta P by delta T, 2m v1 x divided by 2l by v1 x. So 2 will get cancelled, v1 x will go to numerator, it will become v1 x square, m by l v1 x square. Okay, this is nothing but what, our F1 x, which we got it as m v1 x square divided by what, L. So in the similar manner we are going to calculate about f2x as well as what, f3x. Okay, different molecules, first molecule, second molecule, third molecule, like that, nth molecule, f1 x, only in x direction. So total force which is applying towards x-axis is nothing but what, fx, which is given by f1x plus f2x plus so on plus fnx. Clear? Plus so on plus fnx. So pressure on that side means pressure towards the x-axis face we are going to calculate fx by area A. Okay, area will be how much? L square. Correct, no? So shall I erase this part? Shall we go to next part? Or shall I continue over here? Now listen. So we are calculating what, px. So px will be force in x axis. Okay, that means f1x, f2x, all the things if you are going on adding means you are going to get m by, listen, here will L, A means L square, value will be L cube. Okay, m by L cube, inside the bracket we will be having v1x square plus v2x square plus so on plus vnx square. Clear? Okay, now next step. Listen. So now we got px. In the similar manner we can calculate a py as well as what, pz. Clear? Now average pressure we are calculating. Average pressure means pressure in x direction plus pressure in y plus pressure in z whole divided by what, 3. Okay, so average pressure is nothing but what, px plus py plus pz whole divided by 3. Okay, so average pressure. Shall I continue over here? average pressure, or P average is nothing but what? Px plus Py plus Pz whole divided by 3. So just now we had calculated only Px. If I write all the things, means what all the things we are going to get means P average value will be Px value plus Py value plus Pz value. I hope you might have remembered Px value, that is nothing but what? M by L cube. Okay, inside the bracket P1x is, what is that? V1x square plus V2x square plus so on plus Vnx squared. This is about Px. Now plus Py we should have to write. Plus Py is nothing but what? Again it will become M by L cube. Okay, M divided by L cube inside the bracket V1y square plus V2y square plus so on plus Vny square plus one more term, Pz term. So Pz term will be what? M by L cube inside the bracket V1z square plus V2z square plus so on up to Vnz square. This is Px plus Py plus Pz completed. Px, Py, Pz whole divided by 3 again. Whole divided by 3. Clear? Now in these 3 terms, what is common? M by L cube, M by L cube, M by L cube is common, and denominator 3 we are having. So what we can take out common? M by L cube as well as this 3. Inside the bracket remaining is V1x square plus V2x square plus this quantity plus this quantity plus this quantity. What is the value of V1x square plus V1y square plus V1z square? That is nothing but what? V1 square, correct? No? So where I can write now, P average value will be equal to M by L cube as it is. This 3 also I am writing here only. Inside the bracket V1x square plus V1y square plus V1z square is nothing but what? V1 square. Okay. Next plus second term will be V2 square plus so on like up to Vn square. Clear? Now for this quantity, what we had calculated over here, for this quantity, if I divide with n and multiply with n means, what we are going to get? Listen. This term is known as V1 square plus V2 square plus so on Vn square whole divided by n. Now listen. For this complete term V1 square plus V2 square plus so on up to Vn square whole divided by n, if I take root and if I square this term, means value will be unaltered, unchanged value. The square root will get cancelled, again same quantity. This complete term we are going to call it as root of, okay, mean of velocity squares. This complete term is known as root mean square velocity. Sorry, this is square velocity. Okay, root mean of squares of the velocities. So ultimately we are going for the next step where we are going to write VRMS. Shall I erase this part? Okay, quite big derivation, but you have to practice. Now listen. So where we were, P is equal to M by 3L cube inside the bracket we were having v1 square plus v2 square plus so on plus vn square. At this point we had stopped. But what I am telling you, I am dividing with n and multiplying with n, and I am squaring this, and this term I am again, that means here I am taking square root, here I am squaring this term. Clear? Root of mean of squares of velocity. So this term can be written as P is equal to m by 3. L cube is nothing but what? Volume. Okay. This term has VRMS, root mean square velocity, but this is square again, VRMS square, and this n as it is. So what equation we got? P is equal to small m into small n divided by 3 times of volume into velocity. This is small v, velocity, this is volume. Let me write it as capital V. Okay, this is volume, this is velocity. Now, m into n, that means small m into small n, this term. This term is nothing but, n is nothing but number of molecules. M is nothing but what? Mass of each molecule. So, number of molecules, mass of each molecule, you are going to get mass of total gas. So, that we are going to write it as capital M. Capital M by 3 times of V into VRMS square. Clear? So M by 3 times of volume V into VRMS square, very much important. Or you can remember PV is equal to 1 by 3 small m into small m. In place of capital M, small m into small m, VRMS square. Clear? How is the derivation? Shall we go to next step now? Listen. Mass by volume is nothing but what now? Density. So, P is equal to, mass by volume is density, 1 by 3 is remaining here, 1 by 3 rho VRMS square. This is also correct equation, this is also correct equation, this is also correct equation. So, from this complete term, if we want to calculate the value of VRMS, means just cross multiply and you are going to get VRMS value. So, VRMS value will be equal to 3P by rho under root. 3P by rho, this value is inside the root. Shall we go to next point? If you are not understanding the derivation, means watch video 2 to 3 times. It is easy derivation only. Initially we will be considering only one molecule in any desired direction. Then take the components x, y, z. Leave about y and z. It is moving in only x direction, we will calculate. For x axis we will be calculating the value of, first of all, calculate momentum, calculate time. Delta P by T is nothing but force. Calculate total molecules which are exerting force on that wall. Next, after calculating force, similarly force in y direction, force as well as in z direction. Once after calculating all these terms, we will be calculating what? Pressure P only for x. Okay. Next, after Px, similarly P by Pz. Next, after calculating Px, Py, Pz, P is nothing but average pressure, P is nothing but Px plus Py plus Pz whole divided by 3. Next, these steps. Clear? But this term you should have to remember, root of mean of squares of velocities. Clear? Root mean square velocity. Okay? Shall I erase the board? Shall we go to next point? Now, we are going to discuss what is the relation between pressure of gas and its kinetic energy. Relation between pressure of a gas with its kinetic energy. So we got that equation, which is nothing but P is equal to 1 by 3 rho V R M S square. Clear? Now I am going to multiply with 2 and divide with 2. I am going to multiply with the factor 2 and I will be dividing with the same factor 2, where value doesn't changes. 2 by 2. Clear? Now density is nothing but what? Mass by volume. If V value is unit value, means V value is unit value, then what is this term? Half mv square. It is nothing but kinetic energy per unit volume. That means where we are going to treat volume factor as 1. So what we can write, P is equal to 2. Okay, this 2 here I am writing, this 3 here I am writing. 2 by 3, this complete value as E, where E is nothing but what? Kinetic energy per unit volume. E is nothing but what? Ke per unit volume. Ke per unit volume. Now E value, if I want to separate, means E is equal to what? We can write 3P by 2. So kinetic energy per unit volume is numerically equal to 3 by 2 times of pressure of the gas. Clear? Next. Have you understood up to this point? Relation between pressure and kinetic energy. Okay, very important. Practice this 2 to 3 times, you can remember. Only thing is you should have to practice a lot, then only you can remember. Okay. Next one. Next one we are having expression. Okay, expression for average kinetic energy. Expression for average kinetic energy of gas molecules. Now, what is the equation we got earlier? P is equal to, come on, it is nothing but 1 by 3 rho V RMS square. This rho you can change it to what? M by V. Let's change it to M by V. Now, this V, just take it to left hand side. So we are going to get what? PV is equal to what is remaining here? M V RMS square whole divided by what? 3. Capital M into V RMS square whole divided by 3. But from ideal gas equation we know that PV is nothing but what? RT, where we are considering only 1 mole of gas. So PV is equal to RT, RT is equal to MV RMS square whole divided by 3. This is the equation only in case of what? Only for 1 mole of gas. Okay. Now, in 1 mole of gas, this is nothing but complete mass of the gas. Okay. In 1 mole of the gas, how many number of molecules will be there? Avogadro number of molecules will be there. That means how I should have to change this capital M factor? I should have to write this capital M as capital M is equal to small m into Avogadro number Na, where small m is nothing but mass of each molecule. Clear? So if I proceed with this equation means, listen here, RT is equal to, finally our basic thing is we should have to separate what? Half mv square, because we are going for expression for kinetic energy. Listen, Vrms square we are having, but we don't have half. First, leave about that concept. RT is equal to, what you can write here, RT is equal to, capital M is nothing but a small m into NA, okay, and Vrms square as it is, Vrms square only, whole divided by 3 as it is. Okay, so what we got? RT is equal to small m, okay, NA Vrms square divided by 3. Now this NA factor I am going to take it for left side. So if this NA factor I am bringing it to left side means we are going to get RT divided by NA is equal to, what is remaining here, M Vrms square whole divided by 3. Okay, but what we want here, half mv square. That means we don't want this 3, multiply with 3 and half we want, no, 1 by 2 m Vrms square, 3 by 2, 3 by 2. Okay, I am multiplying both sides by 3 by 2. Clear? So I am multiplying both sides by 3 by 2 means here what all the things will cancel. First of all, this 3 will cancel, half mv square. That means kinetic energy equation we got. That is nothing but what? 3 by 2 RT by NA. Listen, half m Vrms square, half m, this term I am writing here, half m Vrms square is equal to 3 by 2 RT by NA. So in last class I had told you about a Boltzmann constant. K is equal to what? K is equal to R by N. Okay, where N is nothing but what? Avogadro number. Now here R by NA means Avogadro number. Here also NA means R by NA, what I can write as K. That means half m Vrms square is equal to 3 by 2 KT or 3 by 2 KBT, where KB is nothing but what? Boltzmann constant. So Boltzmann constant value is nothing but, where I can write a KB value is nothing but what? 1.38 into 10 to the power of minus 23 joule per Kelvin. Clear? 1.38 into 10 to the power of minus 23 joule per Kelvin. Okay. Now, in assumptions I had told you one line. Kinetic energy of the gas molecules is proportional to, or it is dependent on, temperature. Clear? KB is constant, 3 is constant, 2 is also constant term over there. So we had arrived at an expression that kinetic energy of the gas molecule is depending on absolute temperature. Listen, so what I can write, half m Vrms square is proportional to temperature T, or we can write it as average kinetic energy is proportional to, what is this T? T stands for what here? Temperature, but not only temperature, it is absolute temperature. This value is absolute temperature. Clear? So average kinetic energy value will be directly proportional to absolute temperature. Okay, because this 3 is constant, 2 is constant, KB is Boltzmann constant. KB is nothing but what? Boltzmann constant. This is treated as Boltzmann constant. So this is the expression for what? Average kinetic energy. Now here in this term, half mv RMS square 3 by 2 kBT, if temperature is 0 Kelvin means, if temperature value is what? 0 Kelvin, then what will be our right hand side? 3 by 2 kb into 0, which is nothing but what? Overall 0 only. So right hand side value will become 0. So for what? Half mv RMS square value will be equal to what? 0, because when temperature is kept 0 Kelvin. What is the meaning of this? Average kinetic energy value will be equal to what? 0. So in our previous classes, okay, I had told you in classroom teaching, at 0 Kelvin, average kinetic energy of the molecules will 0 and molecular motion will cease at that point. So this point interconnects with that discussion. Okay, average kinetic energy value will be equal to what? 0 when temperature is 0 Kelvin. Clear? So at absolute temperature you can tell that molecular motion will stops, or at absolute temperature molecules possess very minimum energy. That minimum energy is treated as a 0 point energy. That energy is treated as what? 0 point energy. At 0 Kelvin, no doubt molecules will be possessing very small amount of energy. That energy is nothing but what? 0 point energy. Clear? Shall I erase this complete part now? Okay. Listen. So we got the equation for pressure. Average pressure as what? P is equal to, come on, 1 by 3 rho V RMS square, where rho is nothing but what? M by V. Okay, this is not R, this is V. M by V, small v, RMS square. This V stands for volume, this V stands for velocity. Clear? No. Just take this V to left hand side, we are going to get what? PV is equal to 1 by 3. Come on, what we can write? M into V RMS square. Just I had taken this V to our left side. So for ideal gas, what is the value for PV? PV value will be equal to what? RT. So PV is equal to RT is equal to 1 by 3 M V RMS square. Clear? Now, if I want to separate VRMS value, means VRMS value will be equal to 3RT by M. This complete quantity will be inside the root, correct? No? 3RT divided by capital M. This is nothing but VRMS value will be directly proportional to square root of temperature T. So for this equation is nothing but what? VRMS value or VRMS, root mean square velocity, in terms of absolute temperature. And what stands for capital M over here? This capital M is nothing but what? Complete mass. That means molecular weight. This M is known as what? Molecular weight. Molecular weight. Clear? So this is all about today's class. I hope you had understood all the concepts very clearly. So if you are getting any difficulty, means watch the video 2-3 times, okay, and practice more. After getting, just don't leave it, practice maximum number of times. Still if you are having doubts, means just note it down somewhere, okay, in your physics book only, and once college reopens, we can freely ask those doubts. Yeah, keep studying. Thank you.